In this question, a scientist is carrying out a reaction and continuously measures the concentration of lithium iodide. The scientist wants to determine the average rate of change of lithium iodide between 0 seconds and 20 seconds. And for this question, we're given a graph. So looking at our graph, we have the concentration of lithium iodide in the units of molar on the y-axis, and we have time in seconds on the x-axis. So our goal is to find the average rate of change. So one option would be to use our equation. Let's head to our reference sheet. Here's our equation for reaction rate, or in other words, rate of change. The rate is the change in concentration or molarity divided by time. So let's write down that equation. Rate is the change in concentration or molarity divided by the time. Remember, those vertical lines just mean we want the absolute value, which means we don't want the positive or negative sign. We just want the amount that it changed by. So one option would be to look at the initial and final molarities on our graph, look at the time on our graph, and plug them into the equation. However, because on the y-axis of our graph we have molarity, and on the x-axis of our graph we have time, if we were to find the slope of our graph, which would be the change in the y-axis divided by the change in the x-axis, change in y would be the change in the molarity, which would be this. And the change in x would be the time taken for the reaction, which is this. So we can also just use the slope of our line to find the rate of change because of what's on our x and y axis. So you can either look for the numbers and plug them into this equation, or you can find the slope. I'll show you both methods. So if we wanted to use the equation, we would have a look at our initial and final molarity. So we can see here our initial molarity is 2.5. Our final molarity here is 1.5. So that would be our M1 and our M2. So our change in molarity would be M1, which is 2.5, minus M2, which is 1.5. If we put those into our calculator, we're going to end up getting 1 molar as our change in molarity. As for the time, we start our graph at 0 seconds, we end at 20. So our time for the reaction is just going to be 20 seconds. So we can then plug those things into our rate equation here. We'll have 1 for our change in molarity divided by 20 for our seconds. And that gets us 0.05 molar per second for our rate. So that's one way to do it. Now let's do the same question, but with finding the slope instead. So when I'm finding the slope, I like to draw a triangle over my graph. And I'm trying to find my change in y, in other words, the rise on my graph. So I started at 2.5, I ended up at 1.5. So I've actually gone down by 1. So my change in y would be -1, and my unit would be molar. For the x-axis, I started at 0, I ended up at 20. So my change in x would be 20 seconds. So again, we can fill that in to our slope equation down here. So our change in y was -1, our change in x was 20. That gives us a slope of -0.05 molar per second. But remember, we don't actually want the negative sign there. So I'm going to go ahead and put some of these symbols around our equations to show we don't actually care about the positive or negative. We just want the absolute value. So that's going to get us 0.05 molar per second. So you can see we've got the same answer both ways, either by using the rate equation or finding the slope. It's the same thing. So we ended up with 0.05 molar per second. Again, remember, we're always just using a positive number for our rate of change. We're not asking you to say if it's increased or decreased, positive or negative. Here, we're just asking you what is the amount that it changes by per second. Next, we're asked what type of rate this is. This is where we're looking at increase or decrease, consumption or formation. So in this question, because my graph is sloping down, that's telling me my concentration is decreasing. And a decrease means my thing has been consumed or used up. So that's telling me it's a rate of consumption. So this one's going to be a rate of consumption. If the line was sloping upwards, that would be a rate of formation because we're making something or the concentration is increasing.